question 16, the structure of one form of vitamin B3 is shown here. The molecular formula is. Okay, so this is just about counting, but you're going to have to be careful in your counting. So let's start with, well, we can get rid of the O2N. That's the same in all of them. Okay, so I'm not even going to bother counting my O2s and my N. So it's all about the carbons and the hydrogens. So let's start with the carbons. Okay, I'm just going to increase the size of this so I can kind of dot these. So we've got 1, 2, 3, 4, 5, 6 carbons. Okay, so these guys are out. Hydrogens a little bit more tricky because you're going to have to make just, well, but then again, you're just counting. Okay, so I'm just going to give myself another colour so I can use this. Okay, so I've got one over here, and then I've got 1, 2, 3, 4 bonds on the C double bond O, so forget that one. I've got 1, 2, 3, 4 on the connection to the ring, so not that one. I only have 1, 2, 3, so that's going to be a hydrogen up here. I've only got 3, that's a hydrogen, and 1, 2, 3, that's a hydrogen there. So 1, 2, 3, 4, 5. And so therefore A. That's us. Okay, geometric isomerization means I need to have a carbon-to-carbon double bond, which I have, so that's not going to help me. And then I need to have carbons which have different groups on either side. Okay, so I can't have things which are the same. So this one has got a CH2, that's no help. This one is a CH3CH3, so that's not any good. And this one's got a CH2. This one, however, C double bond C, and I've got a CH3, so that's going to allow me to flip. And then on the other side, I've got a CH and then a phenyl group here. So not phenyl, what am I saying? An ethyl group here. So this would allow me to flip as well. Okay, so C. Okay, systematic name for the molecule shown. Now I prefer to actually look at it in kind of slightly bigger structural things, so just to make my life easier. So that's a CH2, CH3. That's a CH2, CH3. And I've got a CH3 coming off the bottom here. Okay, so now I'm just going to name it as if I'm not being given it already, just to make me believe me, as it were. Okay, so longest chain, here we go, is a 6. So I've got a hex. And shortest numbering chain, I'm going to go hex 3-ene. I have got 2 methyl groups, so 3,4 dimethyl. Oh, running out of space a little bit there. And they're both on the same side of the C double bond C, so cis. And we're good. Question 19, we have isomeric amines, trimethylamine and ethylmethylamine. Okay, which line in the table is correct for trimethylamine when compared to ethylmethylamine? Okay, so the difference is that this is a tertiary amine and this is a secondary, which means that this one, most importantly for everything to do with their properties in terms of physically, is the hydrogen bonding. Okay, so our trimethylamine, if we go from this one to this one, has this one on this side has more hydrogen bonding, so that means it's going to have a higher boiling point. So trimethylamine is lower compared to ethylmethylamine. In terms of solubility, it's pretty much the same deal. Okay, in ethylmethylamine we can get hydrogen bonding, oh here we go, between water molecules and this in here, okay, but we don't get that in trimethylamine, so lower and lower, D. The reaction of butanone with lithium aluminium hydride produces, okay, so this is a reducing agent to take us back through our kind of alcohol system. So we've got butanone, sorry, start this again. Okay, the reaction of butanone with lithium aluminium hydride produces, so we are looking at a reduction reaction from a ketone. So let's put the ketone in just because it's easier, I think, if you see it. Okay, here's our ketone. Doesn't matter where you put it because it can only be in the second carbon. Okay, we're going to reduce that, so it's going to go to its secondary alcohol that produced it. And there we go.